everyone. Thanks for joining us today. I'm Gary. I work at Electric Capital. I'm an engineer on the team. And amongst other things, I work on CodeSlaw, which is a search engine for deployed smart contracts on ETH mainnet and then a handful of other L2s. Today, we're going to be talking about source code verification. Briefly, if you're not aware, this is the process in which the raw source code of a deployed smart contract is verified openly, and that code is available for anyone else to verify, to fork, to interact with. We're gonna go over this problem within the ecosystem and the challenges that we face. Joining me today, we have Giacomo from RouteScan, Kaan from Sourcify, and Kirill from BlockScout. So I'll hand it over to them to introduce themselves.
Thank you, Gary. Hi, I'm Giacomo, Jack, for everyone. I am head of growth at RouteScan. We are the world's first unified multi-chain block explorer for EVMs.
Hi, everyone. My name is Kaan. I'm working on Sourcify. Sourcify is a decentralized and open source code verification service.
Hey, everyone. My name is Kirill. I'm the head of research at BlockScout. So BlockScout is an open source blockchain explorer for EVM networks and beyond. And yeah, we've been building tools for verifying smart contracts at BlockScout for many years, and it's always been hard. So let's discuss how to make it better.
Awesome. Thanks, guys. To kick us off, Kaan's going to go over some slides, a little technical intro describing what exactly goes on in source code verification process and the things that he's built.
Yeah, to set the stage for the whole thing, and in case not everyone's familiar with what exactly source code verification is, and even if you know the concept in general, to see what's going on behind the scenes and what the projects are doing, I wanted to show some visuals about this. So what is source code verification? One thing I want to emphasize is when you say verification, it might be confused with formal verification. Formal verification is a different type of verification on programs. Here we are talking about the source code verification. So the problem arises from the fact that the smart contract code on blockchain lives in bytes, in bytecode, in ones and zeros. So essentially, these are not human readable, and from a pure blockchain data perspective, if you want to look at the contract, what the contract does, you'll be greeted with bytes, so you won't be able to read it. And for that reason, what we need to look at is actually the source code. It can be Solidity, Viper, Fei, Huff, any EVM language when we're talking about Ethereum. And if you look at a smart contract code, in this case, I come and show you a code from GitHub, let's say a simple storage contract. How do you really know this code I'm showing you is doing what it's supposed to do? So I show you this code. Oh, at this address 0x123, here is the code. In the end, you are giving your money to this program. It might be doing something else than the code I'm showing. So this process of making sure the code is actually the one that is deployed on chain is called source code verification. Yeah, how do you know this, and so on. If we dive into a bit how this works is, let's say we have these source files installed in my contract, ownable ERC20. What we do is we take these, we feed them into the compiler, let's say Solidity compiler in this case. Then we have a bunch of compiler settings, the version, the optimizer, and so on. And then this will give us, we will compile it, and this will give us a bytecode. In this case, I call recompiled bytecode. Next, we go on chain and ask for the bytecode on chain, let's say on Ethereum network. We get the bytecode, then we compare if these match. So this is a simplification. There are more details into this, but overall, this is how we do the verification.
Amazing. To kick us off, I want to dive into just the problems that we face in this and the importance of having open source code when it comes to blockchains. So my first question for you guys is, why do we need to do this, and like, why is it important?
So I think, first, Kaan was, enough accurate to say that the first thing is they actually are, lending or spending money on those contracts. So you kind of, maybe not you, because maybe you're a user, you find a user, but someone, some researcher or anyone can help you understand what is actually going on. And that actually, ChatGPT, does a somewhat accurate job at understanding what's in it. And so basically it's to understand what you're putting yourself into. And also it's about sharing what you did so that others, since it's open source, so that others can maybe take inspiration from it and build on something better. And for example, I think there's a pretty good example, not so good, but like a successful example of this. And it's like Solidly. It was a project, a DEX project founded by Kronje. And so Solidly didn't really take off as it was planned, but then it was forked and like upgraded from the guys at Aerodrome and Velodrome, and now that DEX is the most successful DEX, even I guess now over Uniswap. So I think that is a successful case when you like share the contract and we make a better product. So,
I mean, for me, it's the basis of everything. Like the whole promise of blockchains is verifiability, open source, transparency, and without the source code verification, nothing happens. You don't know what's going on. You don't know what your code does. Even if you don't understand yourself, the community and the auditors should be investigating this code. For me, I would personally not touch a contract that is not source code verified. It's really sad that still, I think this is much better in Ethereum ecosystem and Ethereum related ecosystems, but it's sad that there are a lot of, let's say, chains or projects that don't emphasize on this, and I think this is in a way something we take for granted in the Ethereum ecosystem.
Yeah, I agree with all that has been already said. I can just add that to me, source code verification is also about security, and pretty much everyone assumes that as long as we build open source projects and the bytecode is deployed on chain and is publicly available, but as long as there are not that many people who can reason about this bytecode in its raw format, so we can't gain a lot of benefits from this being open source, this being transparent, as long as people cannot verify that this exact source code that they are seeing on GitHub, that they are able to review there, that this is an exact source code copy that has been deployed maybe years ago.
I think, I think there's another thing that it's, I think it's just been researched, and I think L2Beat made some steps in that direction. There is like a bit of research that we've been doing on RouteScan since, 2-3 years, and it's to understand how contracts, like smart contract within a single dApp interact with each other, and now they interact with other dApps. Like, I don't know, in the DeFi summer, there were a lot of yield optimizers that interacted with DEXs to optimize on the liquidity pools or whatever. And so it is also a way to understand how the money is flowing and to predict how the money will flow. And so to basically have a better prediction of like the TVL and everything that DeFi Llama is doing also, but you can also do it better if you know how money will flow, because you know how money is interacting, like, how information is like being interacted between different smart contracts and different apps, like about interfaces, let's say.
Yeah, I see. There's a lot of benefits to it. Seems pretty straightforward, right? You deploy your contract, you get the bytecode, and then you like upload your source code to this thing, and everyone wins. I guess, what are the problems that you guys are seeing in the products that you're building when it comes to source code verification?
So I guess as the Verifier Alliance, so just an intro about the Verifier Alliance. I think we didn't.
No, we didn't.
You have that? Yeah. So the Verifier Alliance is a joint initiative between Sourcify, BlockScout, RouteScan, also the consumers of smart contracts, source codes, and other block explorer providers and languages that wants to have an open database of source contracts, so that is, for example, easier for chains to switch from one explorer to the other, or, for example, to have a unified, bucket of everything that no single data provider can actually provide, and so, what was the question? About the difficulties. Yes. So so we launched the Verifier Alliance in Denver, I believe it was.
ETC.
ETC, yes.
It announced in Denver.
Yeah, Denver. Yeah, and so we still have some issues that I think Kaan and Kirill are better suited to tell you about. But one big thing is about coordination. So when you're like a lot of people that basically you've never worked with each other before, and you are working with each other with a strong alignment towards one thing, it's about also finding those other things that you may not be aligned with that maybe are some issues. And also another entity that is involved is Paradigm through SEMCZ. So yeah, there's a lot of people involved, and we had a lot of meetings, and we also host bi-weekly or monthly meetings to coordinate on that. But we have some issues that I think, Kaan and Kirill can tell you better.
Maybe I'll touch on the technical problems a bit. I also have some slides about that. But in general, the problem is it's not always straightforward to match the code, the on-chain, to the source code that you have. There might be, sometimes the bytecode can become really sensitive, and also the bytecode is it's unstructured. It being unstructured it's difficult to make sense of it, and there are a lot of workarounds we need to do to match. For example, these were about more Verifier Alliance, but so one problem I want to mention is the difference between creation bytecode and runtime bytecode. So when we compile a contract, we get two bytecode outputs. One is the runtime bytecode. We in Sourcify at least like calling it runtime and creation instead of bytecode and deployed bytecode. You can see this is an output from the Solidity compiler. Here, the bytecode is the creation bytecode, and deployed bytecode is the runtime bytecode, as we say. We call it creation and runtime because the creation bytecode is the code that is executed to deploy this contract. In this case, the above one is the creation bytecode, and as you can see, it contains the runtime bytecode. What creation bytecode essentially does is execute the first half of this program and then copy the runtime bytecode at this address. And the problem here is, yes, we get the creation bytecode from the compiler, but it is not as straightforward to get the creation bytecode on chain. We can get the runtime bytecode from the RPC directly. There's a ETH getCode RPC call to get the runtime bytecode on chain, but there is no RPC call to get the creation bytecode. So what we do, at least in Sourcify, is we don't index the chain, so we are different than block explorers in that sense. What we do is, okay, now we need to find the transaction that created this contract. Then we look into this transaction's payload. If this contract is an external created by an EOA, good. Then we get this payload, compare it with the creation bytecode, everyone's happy. If it is a factory though, then things get tricky. Then you need to trace use the traces to like to see the intermediate steps inside the EVM to be able to get this creation bytecode. So I find this fact to be a centralizing force within the ecosystem. And for that reason, for example, we are, at least in Sourcify side, struggling a bit more. The other technical problem is that there are like fields, let's say, inside the bytecode that are like changeable. For example, in this case, the compiler puts a placeholder for an address, library address, and this needs to be modified inside the bytecodes. For that reason, we call this transformations. Transformations are the set of changes you need to make to reach the on-chain bytecode from the recompiled bytecode. So these constructor arguments, immutable variables, libraries, CBORAC, so that these are the changes that we need to look into the bytecode technically. So these can get tricky.
Yeah, to continue on this problem with unstructured bytecode and the pain of getting the creation transaction, I can also add that I think that in general, the space of verification of smart contracts lacks a lot of standardization. So we have a bunch of different block explorers with a bunch of different APIs that implemented in different formats, works slightly different, maybe have different API routes and so on. Then we have different implementation of this verification logic, which someone came up independently, and there is no like a single spec that how you must exactly step-by-step verify the solidity of Viper contract. Then we have a bunch of different languages and compilers that work completely differently, have the different API, have the different input-output format, so Solidity, Viper, Half, and so on. So I think that space can gain a lot by doing this standards and writing some specs and creating tests to cross-test every and each of these APIs, implementation of verification pipeline, and stuff like that.
Yeah, and exactly this is the reason why we have the Verifier Alliance. Like this is, in its essence, as Giacomo said, this is a shared database. I want to find the slides. So this is a shared database with a shared database schema. And in that sense, this is like a shelling point for whole verification data. But it's also also an avenue for collaboration. Like we, I think, learn quite a lot in technical terms between each other when we were trying to sync on everything. And so far, this has not been done. So everyone was trying to solve the problem on their own, and the knowledge was being also siloed. Like we don't know what project was learning there. And in this sense, we want this alliance to be a knowledge sharing and, yeah, a shared knowledge platform as well.
Yeah, because it's also fragmented, you know, because if you support some chains, we support some chains, you support some other chains, then we have different learnings from how developers use and you know, build their contracts. And so there are maybe some exceptions that we need to use. For example, there are some chains that do not support Viper, for example. So, for example, we didn't have to support Viper until a few months ago, so that we didn't have that problem. So, yeah.
Okay, awesome. Let's. I have some questions about the Verifier Alliance. I think one common outcome of a lot of OSS and public goods projects is they kind of struggle to gain traction over time. Interest wanes, kind of like the buzz wanes, and the projects kind of just fade out of the spotlight. I guess how are you guys thinking about spurring adoption of the Verifier Alliance and keeping it running and alive?
So, I believe Sourcify was inside the Ethereum Foundation. So still, we got someone watching from there, I believe. Then we also try to do outreach. I believe this is a top-down outreach that we need to do. So we try to get on board Optimism, Avalanche, and over time we will basically try to onboard everyone, every chain that we have relationship with, so that a top-down approach. It is actually more centralized because we would like to everyone to just autonomously use this. But I think standards need to come down from a top-down approach, also because we have to, I think we have to challenge the elephant in the room that is Etherscan, that it's really another top-down approach. Can we take questions?
Oh, yeah, we could do live questions.
Yeah.
Sure.
So I'm a user of your services. We are building an online transaction debugger, like a Solidity debugger. So and we need more information than you currently give us, like you.
Okay, sorry. So we are building a Solidity debugger that you can use to debug online transactions, and we are using your services because, well, ultimately we need the source code. But we need more information than just the source code. We also need, for example, the source maps. And actually, Kaan here was quite helpful in designing a new API in Sourcify that would let us do that. So the question is, speaking of the Verifier Alliance, like you have this common database format, is there also some ongoing effort to have a standard at the like web API level? Like, because we are not talking directly to the database, we are talking to the Sourcify server or maybe to a BlockScout server. So, and that just duplicates the amount of work that we have to do if there's no standardization on this level.
I find a shared API goal a bit ambitious at this stage. I ultimately, of course, want to see that. Now the de facto API is the Etherscan API, which also has its own flows, including typos. But at this, like, I think this shared API is definitely a ultimate goal of this collective. But at this stage, I find it a bit ambitious. If there are other opinions.
Yeah, no, I mean, yesterday I see there was just announced a 7-year plan for Ethereum 3.0, so maybe we can just take a year or two to. But yeah, I believe eventually, we talked about having for example, a front end for this database. So it is, in the plan. Not we don't know when, but we would like to do that because it's also a really useful way for researchers all over the world to simply manipulate, the source code they have and, find patterns. Maybe they can find some, digression bugs or something. When data becomes available and everyone can do whatever they want, there are some unexpected surprises that can happen. So.
Great, thanks for the question. Oh, we have another one.
How do you expect EOF is going to change your validation and your verification?
I don't have a full grasp yet. Maybe you guys have a better.
Yeah, I think in the short term, it will make it even worse for us because we'll just have to support one more bytecode format and one more contract format and just double the effort. But in the long run, I think it brings something to the table because now at the status quo, the bytecode format is unstructured and it's hard to reason about it. But in EOF, there is an idea of containers and there is some static analysis you can do on these containers. And I think it will make the verification a little bit easier to specify, to standardize, and to verify. It will be harder to make mistakes during implementation of this verification pipeline. Right, so in the long run, I think we'll benefit from it, but...
Yeah, I agree. I think the fact that the data will be separated from the code is going to make things a lot easier for all of us, but the transition phase is obviously going to be a bit bumpy.
All right, no more? I guess on that same note, one of the big problems with the way the compiler works and the EVM works is you just kind of send this bytecode. It's kind of gibberish almost. I'm curious, what protocol level changes do you think should be made to help improve the source code visibility and just the developer experience as well, working with smart contracts?
I think it used to be a kind of a debate if this should be kind of included or enshrined in the protocol. I don't remember exactly, but I guess we already decided. I'm not sure if it's like, I don't think it's possible to have smart contract, like the code, the Solidity code or Viper code inside the protocol. I think it's more about improving the tooling to continue this way. For me, it's a bit difficult to have a protocol change for this, and I don't think core devs will like it.
You know, I remember some time ago that I saw that there was an ERC in discussion about on-chain audits. So that is something that, for example, Etherscan does off-chain. And it may be something that, you know, it won't change like drastically, but it will enrich the developer experience. So I believe that's one thing. And yeah, there are a few ERCs that are like here and there are like trying to add few details about how you want to manage contracts and related things. For example, there's a ERC that I just was looking at yesterday, 7785, that it's about having an on-chain registry that it's gonna deprecate the Ethereum chain lists. And that could be something that, you know, if there's an on-chain registry and not an off-chain registry, we could integrate that into the Verifier Alliance and have also a better way of, I don't know, maybe discriminating contracts based on the specific chain. Because, for example, there are contracts that are deployed on the deployer address, on the Genesis address, on the L2 that is like the deployer address, and there are also contracts that are deployed on the same contract address on multiple chains. So maybe we could do some work around there. I'm not really sure what, but I see that there's some potential in enriching the developer experience for a L1 plus L2 Ethereum future, let's say.
Yeah, I also don't see how we can change something at the protocol level to benefit the verification ecosystem, but I see that a lot can be done in the infrastructure part. So in all the tooling, Foundry did a good job, but I think we can go even further and to make it so that verification is done by default, so that people don't have to think about API keys, they don't have to think about different specific endpoints to a certain block explorer. They don't have to rerun this verification multiple times to verify their contracts on multiple sources and stuff like that. Then we can also to push from the user side and from the stuff like wallets, so that wallets show different warnings, for example, to users if they are interacting with the unverified contracts, and then if users care enough about such warnings, maybe they can push for the protocols to verify their contracts, and we'll see this increase in the number of verified contracts, in the rate and the speed of how they are verified.
Maybe not on the protocol level, but I'll throw this in a bit at this point, is one thing maybe worth exploring is a bit ZK in this sense. This is also an idea that we are exploring in Sourcify and trying to understand what's possible. If you have knowledge, please reach out to us. Maybe make contracts self-verifiable, like if you kind of ZKify the compiler and you put the proof on chain, and then without even needing a verifier like us, you can prove yourself that, okay, the output of the compiler from this source code is this proof, maybe.
Oh, you mean like verify it on your own, like ZK proofing the contract on chain and trying to, I don't know, match it offline?
Yeah, sort of. You don't need to run a full compilation. You can maybe have a self-evident proof that the source code is actually matching. But at the end, it's not possible. I don't see it's possible to put the source code inside the protocol or in any way. But maybe there's some exploration in ZK here. Just throwing this at the stage.
Or maybe, since we're like, I don't know, saying things that are theoretically possible, thinking just as we have DA layers, you know, data availability layers, we could have smart source code layers. Like you can post data, whatever, and then at the creation ticks, you can just post the source code on a different layer than maybe, I don't know, Celestial. So is like, I don't know, targeting one gigabyte blocks. So maybe they will have enough block space to also host tens of source codes in a block. Yeah.
I think Sourcify does a good job here with the automatic fetching of source code from IPFS, as far as I remember. So as long as the developer or someone else puts this source code blob somewhere on IPFS, and the Sourcify is able to detect automatically and match by deriving the metadata from the deployed bytecode. So here the people might not even think about this idea that they need to go somewhere and verify their contracts.
Yeah, that was, I think, the idea with the IPFS hash. If you don't know, I added some stuff about that here. There has been, especially the Solidity compiler, tried to work around this by putting an IPFS hash of, let's say, the compilation. So the compiler by default appends this byte string at the end of the contract, and this is an IPFS hash to a file called metadata. This contains all the information about the compilation and ABI and how to interface with this contract. So this is still done by the compiler, and the idea here was to work around this. The idea is to have all the contract data on IPFS, and you can fetch yourself and verify. But then turns out this is both a bug and a feature, because then this becomes quite sensitive, and I think the community is divided in this front if this is something we want to have or not. And at Sourcify we're supporting this, but still has been quite unclear how to go about with this. We have a question. What's the pushback against the? Yeah, I can rephrase the question. What is the pushback against this? The thing is, the metadata file is a JSON file that, for example, has the source file paths, and these paths can be quite sensitive. So if you put your source file to another path, then give it to a compiler again, the reproducibility of the whole thing reduces. That means, and also especially if you are using a create2 contract, then the whole bytecode changes, which in turn changes the contract address. That's one reason.
I want to move on to a question more about the ecosystem. I think that the way that the compilation and contract creation is done is kind of led to this world where, you guys mentioned it, like we improved the tooling around the process, we built tooling to do the verification. And that's kind of led to Etherscan being pretty much the de facto place that almost all the source code is verified first. I'm curious for Giacomo and Kirill, you guys work at Block Explorers. Why should Etherscan give this data up? It's kind of the biggest moat, I think, in their business. It's like one of the only sources of private data within like crypto. So yeah, I'm just curious your guys' thoughts on that.
I have a very simple answer for this. It's because they index Ethereum, so they should at least a little bit align with the Ethereum ethos, that is of being open source and collaborative and inclusive. Yet they are not. So yeah, that's like, I'm not much of a technical person. So I have a degree in computer science, but I'm not much of a technical person. But I use my technical skills to like try to convince as many chains as possible to avoid using Etherscan and instead use our Explorer. And so far it went a bit well, not really good as I hoped, because I'm super ambitious about this, but we transitioned 2 explorers from Etherscan, that is Bobascan and Snowtrace. And we also convinced a few chains to use us instead of Etherscan when they were choosing about the Explorer provider, because we're cheaper and we're faster and we're also more inclined to open source projects. So I believe when actually Sam CZ from Paradigm DM'd me about the opportunity of the Verifier Alliance back in November 23, I was really excited about it because it is actually what we need to do. Because the thing is, it's okay to compete, but it's not okay to lock in. So and they have a really bad way of not giving back anything. So, and this is something that I tell everyone because this is the biggest issue that we've had, and I think everyone needs to know this. So when we transitioned Snowtrace, the Avalanche C Chain Explorer, C Chain had around 1.5 million contracts between mainnet and testnet. So per the contract with the Avalanche Foundation and Ava Labs, they were, the contracts are of the chain. So the source codes are of the chain that they're in. So they had to export their contracts. But yes, they did. They sent us a dump of 1.5 thousand contracts, 99.9% less than what we asked. So we had to find other ways to import those, and eventually, eventually a lot of, we were also integrating a lot of tooling, hard hat foundry, so everything would, became much easier. But the thing is, they really were not collaborative at all. And I hear a lot of chains that are simply, and they say to me, we have the hands tied. We cannot change the block explorer because of this, and that. Maybe someone, I don't know, for example, Optimism. Optimism is under Etherscan, optimism.etherscan.io. If they even change one letter, that's going to be a pain in the ass for developers to just change the one letter across thousands of lines of codes and repos and whatever. So that's a huge lock-in. So they need to stay with that and to pay those money. And on average, a chain pays from $1 to $2 million a year. So that's really bad. Can please tell something more?
Yeah, I agree with everything.
Why should you not?
Don't have much to add, but yeah, I think that if Etherscan even cares about their clients and their users, that they must give up their contracts, because this is not only about sharing with these contracts with other block explorers and their competitors or whatever, but for sure sharing those contracts and importing them automatically in different tools improves the security for the users who are trusting their funds and their life with the blockchains that are supported by Etherscan, right? Because if these contracts are automatically available on public data sets and can be automatically imported in different static analysis tool or security analysis tool, or different researchers and security analysts can do some research and find some bugs in those contracts without manually importing contracts one by one from Etherscan, right? Then the security for all users, for all Etherscan and all blockchain users will be greatly improved. So if Etherscan cares about that, then I think the answer is obvious.
Yeah, I can speak more from a pure source code verification side because we are not a block explorer. So I think, of course, Etherscan provided a lot of value to the ecosystem, but it's, and also, like I at least personally I'm in touch with quite a lot of Etherscan people. They're really nice people. I like collaborating with them, but Etherscan people is of course different than Etherscan as the entity. So I kind of want to approach this in two sides. One is I think we need to change the tooling to break this monopoly at the pipeline, at the contract pipeline. One example we did was the Remix plugin. We worked on a unified Remix plugin, and now the contract verification on Remix is done on a single plugin that sends contracts to everywhere. I don't see why would anyone want to verify at Etherscan only and not on everywhere. Like, because one, you want to share data everywhere. You want your contract to be verified by everyone. If it's not verified by someone, then there's a problem, obviously. So we at Sourcify are trying to push the ecosystem in this direction, and for that reason we came up with the Remix plugin that has Sourceify, Etherscan, BlockScout, and RouteScan. So you can easily, if we can run the video, you just compile the contract, give the address, give the chain, yeah, and then it gets verified everywhere. So this is one part of it. Attack the problem at the pipeline before the contract is being sent. And the other part is I see is basically community pressure. I think
Developer community pressure.
developer community pressure, yeah.
Yeah, that's the single thing that
Yeah, I think this is like the elephant in the room not being talked in the ecosystem. Basically whole, like this only gets recognition when Etherscan goes down for a couple of minutes and we're like, oh my God, like Etherscan is down. We can't look at the chain data. Maybe
it seems like the chain is down.
Yeah, and it seems like the chain is down. And maybe we should do something about it and be loud about it.
The first thing is, I think, a lot of chains have it, but not all, is have 2 block explorers, at least. This is like a normal avoiding single point of failure situation. Like you need to have 2 things, because if one gets, breaks, the other will function, and it's a simple, security 101. And so, yeah.
It's even better if one of those 2 explorers is open source.
Yes.
Yeah, that's along the lines of the next question I want to ask. What do you think is missing from the industry or the ecosystem to add more incentive for teams to verify their source code? I think some of the ideas that we've kind of thought of are, some social pressure, some badges. Have you guys thought about anything that could add more incentive for teams to actually do this?
Shame.
I believe right now there are a lot of rules in place, but only for tokens. So right now, when you deploy a token and shitcoin or whatever, you need to verify it. Otherwise, that will not be verified, and the DEX screener or DEX tools or whatever do not have, or other like token security tools cannot read the contract, and it cannot tell like if the supply is locked or whatever. And so nobody will buy your token if they don't have some security guarantees. But that only happens with ERC20 tokens. I haven't seen this behavior for NFTs or for other types of contracts. And we are now seeing a lot of non-financial applications being built, like social and so on. And I do not see the pressure to verify those types of contracts, honestly.
Yeah, for me it's really simple. If a contract is not verified, don't interact with it. If you are a wallet, tell your user not to interact with this contract. I think it's pretty straightforward. We've been telling this all the time, and unfortunately, we haven't really seen wallet teams implementing this yet.
We have a question from the audience. Is there any plans for the Verifier Alliance to verify other languages such as Rust or Cairo?
I think maybe it's good to clarify what a Verifier Alliance does here. Verifier Alliance is not a single verifier. We are different verifiers, so we can separately start verifying Rust or Cairo and start writing in the database ourselves, but the Verifier Alliance does not verify something. So if, for example, BlockScout tomorrow starts supporting Rust, then it will be supported in Verifier Alliance as well. So it's about the verifiers, not the Alliance itself.
And I would say that it's a really big defocus, personally, but I think also for BlockScout maybe, because it's, EVM deployments are really flexible and replicable. While I don't know Rust, maybe you're talking about Cosmos or Solana, and Cairo. Cairo may be one of the, because it's like extension of Ethereum, so it might make sense. But I'm anticipating that since there will be a lot of alt VMs built on Ethereum, then there will be a lot of, Aztec. I think there was also Noir. There were a lot of programming languages being built on top of Ethereum, Fuel, for example. And so, yeah, in the future, yes, but it takes time.
Yeah, I forgot to say, we are more EVM focused at this stage, but if you have contract data, still just approach us, then we can see maybe not today, but tomorrow what we can do about it. I think not only EVM data, contract data should be public and easily accessible, but all contract data.
All right. Thank you guys so much for your time, and thank you all for joining us for this panel today. That wraps up our time here.
Thank you.
Thank you very much for the panel, fellas. So that was the end of the last session of the day. Thank you very much for coming, and we look forward to welcoming you in this room tomorrow.